Okay, so the question here says we should calculate the angle. We should calculate the angle that OA makes with the base. So the angle that OA makes with the base. So we'll be talking about this angle between AM and OA. So what we do is, firstly, we need to calculate the value of this. So what we are simply going to do is to use Pythagoras theorem. Since we have got a square base, we can say 10, 2 squared plus 10, 2, rather 10, 5 squared plus 10, 5 squared is equivalent to x squared, because I'm looking for AC. So then using a calculator, 10, 5 squared plus 10, 5 squared, it gives me 220,5. Then the square root of 220,5, that gives me 14,8. So AC is equivalent to 14,8. So if it's equivalent to 14,8, I would then say AM is equivalent to half of AC, because I want to use AM only. So that will be half of 14,8, which is equivalent to half of 14,8. It will give me 7,42. So I've got AM as 7,42. So now to calculate the angle that I want, I'm going to say I want to use AM and OM. So I'll use tan theta to say tan theta is equivalent to opposite over adjacent. Okay, and my opposite in this case is the height 24. That's my opposite, which is 24 here, over the adjacent is the value of AM, which is 7,42. So 7,42 is equivalent to, so tan theta is equivalent to 24 over 7,42. Then theta now is equivalent to tan, second function of 24 over 7,42. Okay, so this is second function, tan 24 divided by 7,42. Okay, so that gives me 72,8. So 72,8 here degrees. That is the value of the angle between OA and the base. Okay, so the question here, it says we should calculate the volume of the frustum. Calculate the volume of the frustum. So what we are simply going to do, the easiest way to do this one is to make sure that you write down first you write down first the formula of the volume. V is equals to 1 over 3 AH. That's the volume according to the table that is given, the data that is given here. That's 1/3 AH. So for that one, we are going to say we are going to calculate the volume of the main frustum. So we'll say the volume of the pyramid. We're going to say 1/3 times the area of the base, which is 10,5 squared, times the height, which is 24 from the initial pyramid. So that's what we have, and we can punch that on the calculator to say 1/3 1 over 3 times 10,5 squared multiplied by the height, which is 24, and we are going to get 882 cubic centimeters. So the easiest way to go about it is to multiply this volume. If we want the volume of the frustum, we'll say that the area of the bigger pyramid, the volume of the large pyramid minus the volume of the smaller pyramid. The large pyramid is the main pyramid, and the smaller pyramid is the one that has been removed for us to remain with the frustum. So for us to find the volume of the frustum, we are subtracting the two volumes so that we get the volume of the frustum, F. But then the volume of the smaller pyramid, we can use the scale factor. Suppose that we are using the heights. So the main height of the whole thing is 24. So we can say 24 subtract 16 to give us 8. So the smaller pyramid has got the height of 8 centimeters. So for us to find the volume factor, we simply say 8 over 24 cubed. This is the scale factor cubed multiplied by 882. Then that will give us the volume of the smaller pyramid. So we say 8 over 24 cubed multiplied by 882. So that gives me 32.67. 32.67. That is the volume of the smaller pyramid. So we say the volume of a larger pyramid minus the volume of a smaller pyramid, it gives us the volume of the frustum. So the volume of the larger pyramid is 882 minus 32.67. It gives us the volume of the frustum. So we say 882 on the calculator. 882 minus 32.67. That gives us 849.33. So the final volume of the frustum is 849.33.